Well, I'm not going to be talking about cave biology tonight. I'm going to be tapping into a slightly different vein. I'm going to put on my space scientist wannabe hat. On July 16, 1969, Neil Armstrong and Buzz Aldrin made history. They were the first humans to walk on the moon. The last manned-moon mission took place in 1972. It has been over 42 years since humans have walked on another planetary body other than the one right beneath our feet. Ever wonder where we would be as a species if we continued to push the envelope of space exploration with that same degree of vigor that we applied during the space race? I know that I sure have. Yes, and this is old school. This is the Bill Shatner version of the Enterprise. Now, I have worked with NASA researchers, engineers, and various planetary scientists on numerous projects since 2005. We've studied caves in the Atacama Desert of northern Chile, the Mojave Desert of southern California, and even the Kau Desert on the Big Island of Hawaii. We have flown 3 missions on NASA aircraft to collect imagery so that we can better detect caves, and we've even collected imagery from a hot air balloon platform. Through this work, we are identifying the best techniques for detecting caves on Earth using thermal remote sensing imagery. But progress has also been made to find caves on both the Moon and on Mars. In 2008, I was co-author on a paper revealing tremendous vertical pits on the Martian surface. Since then, colleagues of mine have identified over 2,000 cave-like features on Mars. Planetary scientists have also identified over 200 cave-like features on the Moon. Last March, I had the opportunity to work with NASA JPL engineers to field test the world's first rock climbing robot. One day, a robot like this may very well enter a cave on Mars and explore it for us. Well, as it turned out, I was the very first human to belay a robot on rope, as you can see featured here. Well, feeling pretty smug in my accomplishment, I shared this image with one of my close friends in the Explorers Club, and he quipped, "I'll be impressed when it's the other way around." And I was like, yeah, man, so will I. Now, I've been involved with all this work over the years for numerous reasons, but perhaps most importantly, I believe once we break the chains of low Earth orbiting space stations and we ultimately settle the Moon and Mars, our planetary outposts will be built underground. In order for us to become a multi-planet dwelling species, at least temporarily, we're going to have to return to being cavemen and cave women. Now, I don't anticipate us having to retreat into caves to escape the clutches of hungry or even angry aliens. But if caves existed, but if life existed on Mars, or perhaps still exists on Mars, we're going to find that evidence underground. Mars is subjected, well, both planetary bodies, both the Moon and Mars, are subjected to heavy meteor impacts, extreme temperature fluctuations, and cosmic radiation. Violent windstorms are also quite common on the Martian surface. As far as setting up habitats for humans to actually live on Mars and on the Moon, if I had to pitch a tent anywhere, I sure as heck wouldn't want to do it on the surface. Subterranean Moon and Mars are going to be our best locations for setting up camp. Here we can build astronaut or speleonaut shelters. And this is because we will be setting up astronaut or speleonaut shelters underground. And this will be the safest and best location for working underground. Here we can develop and refine technologies for growing food underground, for human habitats for power generating systems, water systems. We will also be able to test and refine robotics for cave exploration, as well as the power and communication systems that will be required for underground robotics on another planet. Also, access to water is going to be important when we go to Mars. A recent study predicts that the most likely place for us to find stable water ice on Mars is going to be along the equatorial region of the red planet. Now, the reason why this is so important is because once we send a team to Mars, they'll certainly want to come home at some point. Currently, most of our technologies afford us but a one-way ticket. Access to significant water ice deposits can be used to make hydrogen fuel for the return trip, but may also be used for human consumption. But perhaps one of the most compelling reasons to explore caves on Mars is that age-old question, does life exist there? Although it'd be really cool if we ran into Marvin when we were exploring Martian caves, I don't expect that to happen. But if life existed or exists there, we're going to find it underground. Surface conditions on Mars, as I mentioned earlier, are most inhospitable. They are bombarded with cosmic radiation, subjected to violent windstorms, and extreme climatic events. Preservation of organic material on the surface is most unlikely. However, because caves are buffered environments, organic material may exist. And we know this because of our study of Earth caves. There are organic materials that are hundreds to thousands of years old. For example, we found human remains and basketry and cloth made from humans that is hundreds to thousands of years old. From a cave on Grand Canyon, we know that ground sloth dung remains for up to tens of thousands of years old. The last time ground sloths roamed the Grand Canyon was during the Pleistocene. So these are the places where we could find evidence of life, if it ever existed there. In August of 2014, just 2 months ago, NASA made this big announcement. We're going to be sending humans to Mars sometime in the 2030s. Now, I questioned where are we in terms of being able to do this. But they believe that we have the technological capabilities, and at that time, this rocket here, known as SLS, the Space Launch System, will be online, and at that time, we will have the heavy lift capacity to get us to Mars. This past December, a workshop was held called Affording Human Exploration of Mars. Participants here concluded that we currently have the technology to get us to the red planet. However, and they stated this as a tremendous caveat, is in order for that to happen, it's going to take sustained financial commitment of the federal government and the private sector, as well as broad international collaboration and support. And there were a few other things that they mentioned that I felt worth sharing with you all. And first, they stated that all essential human and robotic missions should be focused on getting us to Mars. They also stated that all essential robotic and human precursor missions should be designed in such a way that it enhances our technology and our capabilities to get to Mars. And finally, this was kind of mentioned as somewhat of a meh statement, at least that's how I interpreted it. They said that it may be desirable to establish a semi-permanent lunar base. Well, when I read all this, I felt great. I was like, holy mackerel, my ideas aren't half-baked. At least some of them aren't. Because I've been thinking along these same lines for years now. I believe that we need to return to the moon, establish a permanent base there. There we can test semi-autonomous robotic capabilities, communication and power systems that are going to be required for operating robots underground. We can also test and refine habitats, water generating systems, power systems, and even greenhouse technologies that will enable us to grow our food underground on another planet. It will also be desirable to refine spacesuit technologies and related equipment for living and working underground. We can then take all of those lessons learned from our lunar classroom and apply it to Mars. Now, this is my idea, this is my vision of how I think that we can successfully get to Mars, safely back home again, and perhaps one day even establish a permanent base there. But where are we in terms of what NASA refers to as technical readiness for those three technologies that I mentioned earlier: robotics, human habitation, and related equipment? Well, we know the preliminary testing is underway for the world's first rock climbing robot. However, this technology is still in its infancy. We pretty much have to tell the robot what to do. There is no autonomy built into the robot. We have to tell the robot how to move each leg, how to place each foot, and while it's in the field, it has to be tethered to a human. A lot more work needs to be done before this robot can enter a cave, make some decisions about moving through the cave, and perhaps even conduct some of the scientific experiments that are going to be required to ultimately address some of the questions that we would have about a cave on Mars and how we can ultimately perhaps settle it or explore it for life. Also, we need to develop a speleonaut toolkit for living and working efficiently underground. Presently, no such toolkit exists. In December, I'm going to be testing both motorized and mechanical rope climbing equipment while wearing a pressurized spacesuit. And this is going to be part of a project to identify the types of technologies that we're going to need to live and work underground on another planet. Also, colleagues are currently developing prefabricated inflatable habitats. And the idea is that one day a habitat similar to this may be inserted into a cave, inflated, and used as an astronaut base. But this technology is also in a very early stage of development. All of these technologies that I just mentioned are dramatically underfunded to not funded at all. If we're to be serious about a human mission to Mars, then the rubber needs to meet the road in terms of properly funding these key elements of robotics, human habitation, and related equipment. These things will be required for humans to make footprints on the surface and subsurface of Mars. Last March, I had the opportunity to speak with the entire fifth grade class at D. Miguel Elementary School in Flagstaff, Arizona. I was talking with them about a lot of the same things we're talking about here tonight. One bright-eyed student raised his hand and asked me, "What are we going to do when we mess up things so badly here on Earth that we can no longer live here?" Well, I thought about that a while, and I realized that I have no doubt that a human mission to Mars will have a profound change on humanity. At the very least, it's going to inspire future generations of scientists, engineers, and even artists. It's also going to result in the development of technologies that are going to improve our qualities of life in ways that we don't even recognize yet. That said, I don't think we should use our desire or our ability to go to Mars, to become a multi-planet dwelling species, as an excuse to continue business as usual here on Earth. There is virtually no place left on this planet that we can go where we do not find evidence of humans. We have infiltrated just about every nook and cranny of our biosphere. Our impacts are so immense that scientists refer to the current epoch as the Anthropocene. Global climate change is predicted to alter agricultural crop yields in many of the places where we grow most of our food. Our lack of desire or our inability to change our consumptive habits may very well jeopardize the ability for us to grow our own food on this planet. Acidifications of oceans are killing coral reefs. Coral reefs serve as nurseries for many of the fish species that we consume. Not to mention, numerous coastal societies rely 100% upon the bounty of the ocean for their very sustenance. The unprecedented loss of natural environments and biological diversity is off the charts. We're losing species at 1,000 times the rate that we were prior to humans. And that is predicted to increase to 10,000 times as we move into the future and these sort of activities continue. In 1990, Voyager 1 took this image of Earth from nearly 4 billion miles away. It inspired Carl Sagan to refer to our planet as the pale blue dot. This tiny, insignificant speck of dust, this minute pixel, That's our home. That's the only place any of us will ever call home. So we mustn't forsake our responsibilities here on Earth as we cast our eyes heavenward, to the moon, to Mars, toward a multi-planet existence. Our planet is by far most important to the future of humankind. Thus, we should protect, conserve, and embrace what we have left right here, right now, on this pale blue dot. Thank you very much, and have a wonderful evening.